right, kiddos, let's look at page 2. We are still looking at central angles. So on number 8, we're asked to solve for x. And look at all of the things that are going on here, okay? We know that arc RS is 6x plus 33. We've got 28 degrees here for UT. We've got 45 degrees here for RV, okay? And so if you'll notice, this right here is a diameter, VS. Now we know that the central angle and its corresponding arc are congruent to one another. So if VR and RS are on the diameter, then this arc has got to equal 180 degrees. So that tells me that 6x plus 33 plus that 45 degrees has got to equal 180 degrees. And again, notice, this is on the diameter, so it's a semicircle. So semicircles are equal to 180 degrees. Go ahead and add these two constant terms together because they're on the same side of the equal sign. Okay, and so that's going to give us 78. Let's solve this two-step equation by subtracting 78 from both sides. And that will give me 6x is equal to 102. And then when I divide both sides by 6, I see that 6 will go into 10 one time with 4 left over. Bring down your 2, and 6 will go into 42 7 times. So I get x equals 17. Now go back to the original question and make sure that you answered it. It says solve for x, and that's exactly what we did. So x equals 17. Now looking at problem number 9, we're looking for arc EF. So let's find arc EF. Is right here. Okay, now if you'll notice, DE and EF are on the diameter DF, so we know that these two are 180. If you'll notice, EF and FG are on the diameter GE, so they're going to be 180 degrees. And also these two angles, this one and this one, are vertical angles. So because they're vertical angles, we know that they're also congruent, so their arcs are congruent. So the first thing I'm going to do is I'm going to take that 15x minus 7 and set it equal to 13x plus 3, and I'm going to solve for x. That way I can plug in x and figure out what the degree of those two arcs is going to be. So let's add 7 to get 2x is 10. And then divide both sides by 2 to get x is equal to 5. So if I know that x is 5, I can go right here and I can do 13 times 5 plus 3. Okay? Okay, so we got 68 degrees here and 68 degrees here. Now for my missing arc that I'm looking for, since both of these are on a diameter, I can simply do 180 degrees minus 68 degrees gives me 112 degrees. So that means the measure of arc EF is equal to 112 degrees. And be certain, because it is the measure of the arc, to put the degree symbol at the top. Okay, in the circle below, we have a radius of 15 centimeters, so that could be ZU, ZV, ZW, ZX, or ZY, all kinds of radii. Find each arc length. Now, to find the length of the arc, this is not the degree of the arc. Remember, the degree of the arc is going to be equal to its central angle, which is what we've dealt with in the previous problems. The length of the arc is going to go back and deal with the circumference. So the formula is the arc length is x. X is going to be the degree of the arc times c, which is the circumference of the circle, divided by 360. So the first arc length that we're looking for is VW. VW is found right here. Okay. Now, if you'll notice, these two angles are vertical angles. So they're congruent, so their arcs are congruent. If this one's 26, then this one is 26 as well. Okay, I know that XU is a diameter. So if this is 90, this right here also has to be 90, because 90 plus 90 is 180. So to find the degree of VW, I can do 90 minus 26, which is 64 degrees. And now I'll plug that into the formula and I'll solve for the arc length. So L is equal to X, which is the degree of the arc, times the circumference of the circle. Since we have a radius of 15 centimeters, I'll do 2 times pi times the radius. And I'll take the entire thing and I'll divide it by 360. Okay, let's go to our calculator. Okay, and we'll have 64 times 2 times pi with our pi button times 15. And we'll divide all of that by 360. So looking at the values, let's go out 2 decimal places. If we go out 2 decimal places, you'll see the 5 rounds this 5 up to a 6. So we'll get 16 and 76/100ths. So the length of the arc is 16 and 76/100ths. We're talking about centimeters, so the arc length will be in centimeters. Now that was a minor arc, so let's find this major arc, UXV. Okay, so let's go back to our circle and figure out where UXV is. All right, that's going to be the whole entire circle, isn't it? UXV. Wow, okay. So to find the degree, the whole circle is 360 degrees, so I can go ahead and subtract that little part that we're not using, which is 26 degrees. So that's going to give me 334 degrees for the degree of my arc. So let's plug it into the formula. 334 degrees times the circumference, 2 times pi times the radius, which is 15, and then let's divide the whole thing by 360. So back to the calculator. Okay, so the degree of the arc is 334 times 2 times pi times the radius divided by 360. So once again, let's look at our answer here. A 0 will not round the 4 up, so we're going to do 87 and 44/100ths. So the length of the arc is 87 and 44/100ths, and we're still dealing with centimeters. So that's the length of the arc. Okay, so again, when you see M in front of your arc, that means to find the degree of the arc. When you find the length of the arc, that's when you use your formula. Now the next section, number 12, is chords and arcs. Okay, so remember what we talked about. If you have the center of the circle and the center is equidistant from each chord, what that is telling you is that your 2 chords are congruent. These little boxes right here, the right angle boxes, when the radius or the diameter is perpendicular to the chord, it bisects the chord into 2 congruent parts. So D to the radius intersection and the radius intersection to C are congruent. C to the intersection to B are congruent. And since the 2 chords are congruent, all 4 parts are equal. Now this line not only bisects the chord, it also bisects the arc as well. What we have here is the measure of arc DC is 12x plus 7. Then we have CB, which is 18x minus 23. We're looking for DAB. Okay? So if we can find these two and solve for x and find these 2 arcs, then we can figure this one with 360 degrees. So because of this little perpendicular box right here, I know that these 2 arcs are congruent to one another. Okay? Or not the boxes, the equidistant. So I can do 18x minus 23 is equal to 12x plus 7. Go ahead and subtract that 12x from both sides, and that'll give you 6x minus 23 is equal to 7. Add 23 to both sides, to get 6x is equal to 30, and divide both sides by 6 to get x is equal to 5. Once we know what x is, we can plug it in and we can figure out what our arc measure is. So if this is 67 degrees, then this one is 67 degrees as well, because the two arcs are congruent. The chords are congruent, then their arcs are congruent. So 67 and 67 is going to give me 134. Let's subtract that from the degree of a circle, which is 360. And that's going to leave 226 degrees for the rest of the circle. So the measure of arc DAB is equal to 226 degrees. Now looking at number 13, let's see what we've got. We've got our right angles, so that means that the radius is going to bisect these two. Also, it'll bisect these two, and these two will be congruent. Okay? It also tells me, and same thing over here, it tells me that GP, which is this one, is equal to PH, which is this one. So if these two are equidistant from the center, the two chords are congruent. And if the two chords are congruent and the perpendicular tells us it bisects, then all four parts are going to be equal. And that means all four arcs are going to be equal as well. Let's see what else we've got. We've got GA is 17, so GA is 17 right here. So if GA is 17, then GE is 17. HD is 17. HB is also 17. Then it tells me ED is 37, so that's going to be this arc right here. And AB, which is this arc right here, is 87 degrees. So let's find the measure of our arcs, and we'll have pretty much everything. So if I take 87 and 37 and add them together, and then subtract it from 360 degrees, that's going to be 236 degrees for our four sections of arcs that are left. But if all four sections of arcs are the same, I can divide what's left, and I'll get 59 degrees for each one. So EF is 59, FA is 59, DC is 59, and CB is 59. What about that? Now the first thing it asked me to find is DB. Okay, I'm going over here to our circle. DB is this entire chord. 17 plus 17 is 34 units. EG is the part of the chord. That'll be 17 units. The measure of arc DB, so here's D and here's B, so we're looking for this arc right here. That'll be 59 plus 59, which is 118 degrees. Next we have arc FA, which is 59 degrees. And then finally, arc DC, which is 59 degrees. Okay, and that's going to be the measure of all of our arcs. We've got 34, 17, 118 degrees, 59 degrees, and 59 degrees.